Hello, I am Paolo Marcatilli, and today I will talk about the bioinformatics and systems biology study line at TTU. Before starting, I would like to share with you a little bit of my excitement for the field with a short story about a success story in the field of bioinformatics. One part of bioinformatics is devoted to understanding the function of proteins, and there is this main idea that the primary sequence of a protein that it's encoded in genes, in turn, has all the information about the final conformation that a protein will get into, that it's called a native conformation. In turn, the native conformation is linked to the function of a protein. So in order to understand the function of a protein, we need to understand its structure. And this has been a field or a task that has been around for 40 years, from the 80s, creating computer software, computer programs that are able to predict the three-dimensional structure of a protein, given its primary sequence. And there is this competition that is named CASP that runs every second year, where people try their software, their programs on new proteins in a blind way, so they don't know anything about the structure, they only know the sequence, and then after the competition ends, the results are evaluated and the winner is identified as the group or as the person that has achieved the best accuracy in the models. In this graph, we see the evolution of the accuracy of this is the winner of the CASP competition from 2006 to 2020. And it's on the y-axis, you have a measure of the accuracy. 100 means 100% accuracy. So it's a perfect prediction. And as you see, the accuracy didn't really change from 2006 to 2016. But then in 2018 and even more sharply in 2020, we see an increase in the accuracy that has been terrific. And this is due to the introduction or to the creation of a new software that is called AlphaFold, that is based on deep learning, that was able to bring the accuracy of prediction to an unprecedented level that it's almost as good as experimental data. Of course, this creates an incredible number of downstream applications. Now, we study a new pathogen, we study a new virus, we basically from day zero have the possibility to see the structure of all their proteins. We can use it for protein engineering, we can use it for understanding molecular interaction that happen in the immune system, for example, or to identify new enzymes. And just to show you how impressive is the accuracy of this tool, I'll show you two examples from the latest CASP competition. You can see that in green and in blue, we have the experimental structure and the real structure, and this is almost perfect. Now, this incredible accuracy is allowed by having an incredible amount of data, sequencing data, protein data. We have huge databases that contains hundreds of millions of protein sequences. It has been allowed by applying machine learning and deep learning to biological data. It has been allowed by having a very in-depth understanding of the protein structure, by having analyzed the biophysics and biochemical properties of proteins since many years. So this success story is also giving us some ideas of how bioinformatics works. In bioinformatics, you need to have knowledge about the biological data. And for example, plenty of biologists, biochemists, biotechnologists have transitioned to bioinformatics from the early days. On the other hand, you also need to be able to deal with computers, programming, math, statistics, modeling, and so on and so forth. And what we try and do in our study line is also to acknowledge this diversity, to help the student to get the best of both fields, but also to choose their own path. We have three main study lines that the students can choose from. please remember that you can also kind of merge some of these study lines to create your own personalized study line. The three study lines are bioinformatics methods in life science, biomedical bioinformatics, and infectious disease health informatics. Bioinformatics methods in life science deals mostly with creating new computational tools to analyze biological data. On the other hand, biomedical bioinformatics is more devoted to applying existing tools to solve biological, biomedical, and biotechnological problems. Finally, infectious disease health informatics is a study line that is specialized on creating and using tools to track diseases, and you can easily understand how important this is in today's world. I'll just show you some of the main courses that define the study lines to give you a feeling of what you will be studying. In bioinformatics methods in life science, you will deal with, for example, algorithm bioinformatics, introduction to machine learning and data mining. You also have plenty of courses in the biostatistics, deep learning, and computational biology related areas. So you'll get expertise in everything that is related to modeling data, the so-called data science. And in the end, bioinformatics in itself, it's kind of a biological data science. So it's applying data science tools to biological data. In biomedical bioinformatics, you have computational precision medicine, immunological bioinformatics, and systems biology. And you see, you will get an intimate understanding of many different tools, but even more importantly, you will learn how to use them to solve meaningful biological problems. And lastly, in infectious disease health informatics, you will have fighting infectious diseases, surveillance and epidemiologies of infectious disease bioinformatics, and advanced modeling of infectious diseases. So you see, you will become an expert in analyzing, tracking, and fighting infectious diseases. With the competence that we give, we believe that you will have absolutely no problem in finding a job. And actually, there is a shortage of bioinformaticians nowadays. This is a report from the Novo Nordisk Fund that was published in 2018 that it's named the Danish Bioinformatics Landscape. And basically, they went around and asked to companies, to industries, to hospitals, and to universities how many bioinformaticians they were hiring in 2013, how many they were hiring in 2018, and how many they were thinking about hiring in 5 years' time, so 2023. And as you can see, there has been a sharp increase in hospitals, plus 40% in the first 5 years, plus 30% in the next 5 years. But even more shockingly, in academia, plus 62, plus 87%, and in industry, plus 136, plus 160%. So as you see, this is kind of impressive. And also it covers basically different levels of using bioinformatics. You have core bioinformaticians that are using tools. You have applications that are developing tools, data science, and other domains. So basically, all bioinformaticians are highly requested. And this is just to show in a different way the increase in different fields. And you see that core bioinformaticians, application, data science, and other domains, all of them are growing in the previous years, and they are expected to grow in the future. Basically, we have now technology that can produce high throughput data for genes, for sequencing, for proteins, and for a number of different applications. And the bottleneck is in educating people that can understand this data, that can talk to other stakeholders in the resolving this kind of biological problems, and then can extract information from the data. So the bioinformatician is the person that puts all of this together, that creates value out of this amount of data. what you will be doing during our study line. I mean, there is so many exams in courses that I will not describe them all, but I want to give you an idea of the projects that students do at the end of their master. So I've taken all the current master thesis, and created this word cloud. As you can see, there is a number of things that are recurring here. So you see machine learning, deep learning, patients, disease, predictions, cancer. Basically, if there is something that you want to do, we are doing it. There's so many different projects that you can do, and all of them are extremely cutting edge research and extremely interesting. So to sum it up, the students in our study line usually end up either in industry, Nordisk Christian and so on and so forth, all the greatest industry in Denmark, as well as hospitals, or they do a PhD. There is also a high requirement for bioinformatics PhD. And the unemployment rate is extremely low. It's even lower than the average of engineers at DTU. So that being said, I hope that I gave you a nice overview of the bioinformatics and systems biology study line at DTU, and I'm looking forward to meeting you all. Bye.